12.5, volume of pyramids and cones. This is very difficult to prove because actually, in fact, it deals with calculus. But just know that the pyramid of the same base and the same height as the prism that goes with it is 1/3 of that deal. You don't have to memorize that, you can just use it. Go ahead and draw the pyramid and the formula that goes with it. Draw the cone and write the formula that goes with it. Just 1/3 of the base times the height, the area of the base. 1/3 the area of the base times the height. So in this case, 1/3 pi r squared h. With that, we can start solving some problems, like example number 1. All we have to do in this case is find the base, multiply the height, divide by 3. That's the volume. This is given on the formula chart. Notice this triangle right here is a right triangle. Base, the little base of that triangle is 4 times the height of that triangle, which is 6, and this is going to be multiplied by 1/2. All of this is the capital B. The height of the actual triangle is the perpendicular distance to the vertex at the top. So in this case, 9 divided by 3. Now it just comes down to simplifying and chugging it out. 6 divided by 2 is 3. 9 divided by 3 is 3. So that's just 3 times 4, which is 12, times 3, which is 36. Cone, this is the same thing, Cavalieri's principle. We have our perpendicular height. We're going to assume that's perpendicular for now. And we're just going to do 1/3 pi r squared, which is 2.2, times the perpendicular height, which is 4.5. And obviously with the decimals in pi, we're just going to chug this out. So 1 divided by 3 times pi times 2.2 times 4.5. So 11.78. And this is centimeters cubed. I think I'm going to hold off on this one. Same deal with the guided practice. We'll do some of those in class. Find the volume of the right cone. Yes, in this case, we're going to deal with triangles that we have angle measures of without having known sides. But in order to use our formula, which is the base times the height divided by 3, and since it's a cone, it's equal to pi r squared times h divided by 3. We're going to need to find that r. Notice we have an angle, we have the opposite, and we're looking for the adjacent. That means we need TOA. So I'm going to go ahead and solve for r first. Notice the tan of 65 is equal to the opposite over the adjacent, which is the radius. Multiply both sides by r, divide by tan 65. You get r is equal to 16 divided by tan 65. Reminder, put this in degree mode. I'm going to go ahead and figure out what this is and then store it into r in my calculator. Actually, I'm going to store it into x just to make a quick calculation typing in my calculator. Make sure I'm in degree mode, which I am. 16 divided by tan 65. Let's go ahead and get that. We get 7, r is roughly equal to 7.46. I'm going to store this into x in my calculator, and then I'm just going to write x in my formula because it makes it a lot simpler for me. Like I said, I stored this value for r into x. Then I just have to type pi x squared times 16 divided by 3, and I get 932.68. And this is in feet, and it's cubed. That's it for that one. Example number 4, it's called a composite figure. Notice it's just a pyramid plus a cube. So you just add them up. I'm not going to work this one out, but you're welcome to, and then check it out with the textbook. In fact, I'll go ahead and show you the textbook. Whoops. Just kidding. You'll have to look it up by yourself. This is just another example exploring the cones. Same deal though. All right. And that's all I wanted to show. So that's it for the video.